Hi, this is Mr. Max. I am doing a question here on circular measures, and I hope that you have access to the textbook. This is the textbook y equals mx plus c. But of course, I have retyped the question here. It shows that this diagram shows a sector of a circle, center O, radius 4 centimeters, angle XOB is 5 pi upon 6 radians. You're supposed to calculate, giving your answer in terms of pi, the arc length. So in order for you to use the formula, the arc length formula, you should know that it's radians times the radius times the angle. So in this particular case, I'm just going to say 4 times 5 pi over 6. Well, of course, this is nothing but 20 pi over 6, which you can go ahead and simplify to 10 pi over 3, and that would be in centimeters. Right. Then the next one says you are supposed to calculate the perimeter. Well, what is also now worth noting here is that this distance over here, this is also 4 centimeters. And we have just calculated, in fact, not that one though, we have just calculated um, this value over here, which is that arc length of 10 over 3 pi. So we just simply have to add them all up in order for us to calculate the perimeter. So the perimeter will be 2 times 4, okay, plus 10 over 3 pi. Okay, but of course you can simplify it if you want to. You can just write it as let me just make this. So this is 8 or 10 over 3 pi plus 8. Well, everything here is centimeters. That's the perimeter, the outside. Okay, I brought the diagram down again. They say the area of the sector. And in order for you to calculate the area of a sector, it's very important that you know the formula. The area of a sector is a half r squared theta, where theta is the angle. So I'm going to go a half times the radius squared times 5 pi over 6. So this just has a matter of you grabbing a calculator. That's 16, half of 60 is 8 times 5 pi over 6. Of course, we're looking for area. So, well, you can say 8 times 5, that is 40 pi over 6. And, well, you can simplify this to 20 pi over 3. And this is square centimeters. Of course, you may use your calculator, but remember you must give the value, the answer in terms of pi. Now they want you to find the area of the segment. So what do we have? What do we know? We have the area of sector X or Y, which we calculated as 20 pi over 3. We should subtract that, the area of triangle X or Y. So we need to find this area of this triangle. And the area of the triangle is a half times 4 times 4 times the sine of 5 pi upon 6. So I hope you are quite familiar with the area of a triangle, which is a half AB sine C. And that's the formula that I use. If you have a triangle where the angle is included, uh, and then you have the two sides given like so. So at the end of the day, make sure that you are utilizing your calculator, and your calculator should be in radian mode. So you can go ahead and change the calculator to radian mode. In this case, for display there should be R because of this condition over here. Okay. Now, if you were to do so, if I just had to do the ones in the bracket, that's going to be a half Then 4 times 4, well, 4 times 4 is 16, times the sine of 5 pi. So I'm going to have 5 pi over 6. The reason why, because the angle here is in radians and not degrees. So that gives you 4. So this over here is 20 pi over 3 minus 4. Whatever that answer is, that is going to be the area of the shaded part. And then you can go ahead and obviously give your answer. So I will be saying 20 pi over 3 minus 4. Well, that gives me about 16.9 to 1 decimal place. So 16.9 to 3 significant figures, square centimeters, 3 SF. Okay, right, let's get to part C. Now, part C, really important. They want us to find the length of the chord, so I only drew that. So here we're going to use, obviously, our cosine rule. So if you want to find, let's suppose I'm rewriting this. So if you want to find a square, you say b square plus c square plus 2bc times the cosine of angle A. In this case, xy square equals to 4 square plus 4 square minus 2 times 4 times 4 times the cosine of 5 pi over 6. Now remember your calculator values over there. Now if you were to do that, remember you still have to take the square root of your answer. And it's very important that you don't mess this up, okay? So we're going to grab our calculator, or I can just go ahead and say, well, xy squared, this is 16 plus 16, 2 times, well, this is 2 times 16, times the cos of 5 pi over 6. So in a nutshell, there are 2 terms here, all right? So this is 32 over here. And I'm going to first punch in the negative stuff. So maybe I'm going to grab my calculator. I'm going to say, let's do it from the beginning. 4 square plus 4 square minus 2 times 4 times 4 times the cosine of 5 pi upon 6. All right, let's see what this value calculator give me. Well, it gives me 32 plus 16 root 3. So that's 32 plus 16 root 3. That's that answer over there. And if you want xy, which is what we are looking for, we are now going to calculate xy as the square root of 32 plus 16 root 3. Right, this is not a final answer. So we are now going to see how can we find the square root of surds. This is very important. So I'm going to come back and I'm going to write this answer. So I have 3 questions, where one of them is also here to explain the scenario. So I'm going to come back there. So suppose you have an answer in this form, and you need to find the square root of surd. So what is important is, let's suppose you take 2 numbers. The numbers is m and n. And if you add those 2 numbers, they should give you the same as when you multiply m times n. But you should be careful. That is when you add. When you subtract, you should be careful. So the answer would be the square root of m plus the square root of n when we are done with that. Okay? If, however, you have a minus in there and you get the square root of m minus square root of n, then when you do these, finding 2 numbers that the sum gives you the value of a and multiplying gives you that, then it should be that m should be greater than n. Of course, let's look at 3 scenarios so you can see. So we are looking then for 2 numbers added together, give you 8. And when multiplied together, they give you 15. So that is 5 times 3 and 5 plus 3. So the answer to this question was square root of 5 plus the square root of 3. There you're done. You can actually go ahead and check. So suppose I put the square root of 8 plus 2 root 15. That answer 3.96811. Remember that answer? So if I take the square root of 5 and I add the square root of 3, I will getting the same answer. Can you see that? So that's the square root of surds. Now let's look at this particular scenario here. There's not a 2 there, but 10 can be written as 2 times 5 or 2 times the square root of 25. And there's a reason why I do that. So in this particular case, if I was to do this one, I would say, wait a minute, this is the square root of 30 plus 2 times the square root of 25 times the square root of 5. Remember, the square root of 35 is 5. And this is therefore going to give me 30 plus 2 times 125. Because if you have the square root of 25 times the square root of 5, then you simply multiply those numbers to give you this answer over here. Now, if I was to come here now, and I'm going to do the method that I was doing, what two numbers multiply give me 30, and add them give you, multiply give you 125, and you add them give you 30. Well, you know that those two numbers have to be 25 and 5, because 25 times 5 is 125, and 25 plus 5 gives you 30. So our answer here would be the square root of 25 plus the square root of 5, which we can actually go ahead and clean up. And our final answer in this case would be nothing but 5 plus root 5. This is the answer to this particular question. Okay, when you write the square root of surds. So in the same vein now, let's look at the one that we had, which is the question that we had. Okay, so again, maybe some side work. 16 is nothing but 2 times 8, but I want that 8 in the square root, so I'm going to say 16 equals to 2 times the square root of 64. Square root of 64 give me 8. So I have 32 plus 2 times the square root of 64, square root of 8. Okay. Then basically you have 32 plus 2 times 64 times 3 under the square root, of course. Now, if you were to go ahead, you will have 32 plus 2 square root of 192. So what two numbers are there that multiply, that give you 192, and add that gives you 32? Okay, it will take you trial and error, but the numbers is 8 and 24. When you have 8 times 24, you have 192, and 8 plus 24 gives you 32. So we said our answer would be the square root of 8 plus the square root of 24. Right, I'm going to finish this, but this is what I'm going to carry over to my other question. So if I go back, so we said the answer is the square root of 8 plus the square root of 24. Now remember, if you have square number 4 times 2 plus 4 times 6, this is the same as square root of 4 times square root of 2 square root of 4 times the square root of 6. So this is 2 root 2 plus 2 root 6. And that is our final answer in this particular case. All right, very interesting problem where you don't necessarily have the square roots of surds, but it's interesting to know how you can finalize your answer. So typically in an examination setup, they will probably ask you to give your answer, the answer of chord. But here the question, the tricky thing is they are asking the exact value of that. And you can't give a rounded answer. So this is this 32, the square root of 32 plus 16 root 3 is actually the exact answer, but we don't leave our answer in that form. So I went further and I brought in how do you find the square root of surds, which is a very important aspect for you to learn. Okay, good luck with your studies, and any more questions, just bring them and we tackle them together.